Welcome guys to my new channel which is Ausbildung, that is related to all the competitive exams especially related to electrical engineering, but few subjects will be common to all the branches and also focus will be given on the common subjects of competitive exams like reasoning, maths and also detailed analysis of the previous year papers will be done here. So let's begin with the first session with Ausbildung. So first subject that we will start here will be electrical circuit analysis and synthesis. So we are going to start the first subject, that is electrical circuit analysis and synthesis. So first of all, let us understand what this electrical circuit analysis and synthesis difference is. The two term we can see here, electrical circuit analysis. Second term is circuit synthesis. So what this electrical circuit analysis means, that we will have the input, we will have the circuit elements. These two terms will be known to us, but the term that will be unknown will be output. So we will try to find output in the electrical circuit analysis, and in synthesis we will have input, we will be knowing output, but the unknown term will be the circuit elements. So we will try to find the circuit elements, and these two terms input and output will be known in the circuit synthesis, but we will be circuit elements will not be given to us. We will have to find the z uh, parameters, y parameters, g, etc. So in this way we will differentiate this electrical circuit analysis and synthesis term. So let's begin with the fundamental concepts of circuit element and energy sources. So we will begin with fundamental concepts of circuit elements and energy sources. Okay, so let's start with the circuit elements. So what is mean by circuit elements? So there are three types of circuit elements. These three are resistance, inductance, and capacitance. So let's begin with the first one term, that is resistance. So we all know Ohm's law. Ohm's law. Ohm's law states that the physical condition being unchanged, the current that is flowing through any conductor will be directly proportional to the applied potential difference across it. Means this statement is basically saying V is directly proportional to I, and now when we will remove this proportionality sign, so we will get R term here. So this R will be known as a constant of proportionality, and this is basically this resistance. This is only the resistance. So resistance, what is resistance? So electrical resistance is the property of the material by virtue of which it opposes the flow of electron through the material. Means that will restrict the flow of electric current in the material. So this is the definition of the electrical resistance. So the unit of resistance is ohms, and symbol is this. So here from this formula we get R is equals to V by I. V is what? Potential difference. And unit is volt, and here I is current and its unit is ampere. Now when we will try to find out the power that is being absorbed by the resistor, so that is given by power that is being absorbed by resistor, that is given as P is equals to V into I. V means voltage into current. Product of voltage into current gives power. So that is basically V is equals to I into R into I. So we will get here I square R. So this is power and its unit will be watts. So now after power, we will try to find out the energy. Energy that is lost in the resistance. So this energy that is being lost in the resistance is in the form of the heat. Now we know that energy formula is W is equals to integrating. W is equals to integrating 0 to T E into dt. So that will be equal to P. We'll take P common and here when we will integrate dt from 0 to T, we will get here T because integration of 1 with respect to dt will be T. So here we know P is equals to I square R. Here it will be T. So we are getting I square RT, or we can also say P square upon R into T. So this here we have got the formula for energy that is lost in the resistance in the form of heat. So now moving to the next. So second point is, or second circuit element is inductance. So what is inductance? So inductance is the property of a material by virtue of which it opposes any change of a magnitude or the direction of electric current that is passing through the conductor. Means it will basically oppose the electric current that is passing through a conductor, and here unit of this inductance is Henry, or you can also write H. So here it is given by the Faraday's law of electromagnetic induction. This inductance is given by the Faraday law of electromagnetic inductance. Now, when this wire, when it is twisted, this form, it give rise to the inductance. Now, let us try to find out the formula of this inductance. Now, according to Faraday's law and Lenz's law, VL is equals to voltage across inductance is equals to minus L di by dt. Minus sign shows the Lenz law. Now I here is the current that is flowing through the inductor in ampere, and now when this circuit will be pure inductive circuit and V voltage is being applied on the circuit, so here we'll get V plus VL is equals to 0 and V will be equal to minus VL, or we can also say L di by dt. So now let us calculate the power that is being absorbed by inductor. Power formula is V into I, voltage into current, and V is equals to L into di by dt into I. So this will give L into I into di by dt. Now energy absorbed by inductor will be W is equals to, we all know, integrating 0 to Tp into dt. Now we will substitute the value of P from above equation. 0 to T, P is equals to L into I into di by dt into dt. So here this two terms will be cancelled out and you get L into I into, or you can say I square by 2. So this give rise to half L into I square. This is the formula of energy that is being stored in the inductor. Now next third element is the capacitor. So capacitor is the capability of an element to store the electric charge within it. So that will be called as a capacitance. Now we know formula Q is equals to C into V. Q is the charge that is being stored inside the capacitor. C is the capacitance and V is the potential difference. Now here I is equals to, we know, dq by dt. So here we will get I is equals to C into dv by dt. Now one will integrate this, or you can transfer this dv here. Dv is equals to 1 upon C to I into dt. Here we'll get integrating from V naught to Vt. dv is equals to 1 upon C integrating 0 to t I into dt. So here V naught is the initial voltage across the capacitor, and Vt is the final voltage capacitor. Now here we will get Vt minus V naught is to 1 upon C into integrating 0 to t I dt. That is Vt is equals to 1 upon C integrating 0 to t to I into dt plus V naught. This is the formula of voltage across the capacitor. Now the formula for power that is being absorbed by capacitor is P is equals to V into I, that is giving V into C dV by dt, and then we'll calculate the energy. So it will be given as W is equals to integrating 0 to t into P dt, or you can also say integrating 0 to t into P into C into dV by dt, that is equals to half into C into V square. So this was all about the power energy of the inductor and capacitances. So this was all about today's class. Now we will continue the next session in the next day, and there we will solve few numericals on these all topics. So if you all like the today's session, you can like, share, subscribe, and press the bell icon. And also, if you have any doubt, please comment down below related to this topic. I will try to clear your doubt by replying. Thank you guys. Have a great day. Bye.